others. Thank you for this first session of the day besides the keynote. Hope you all enjoyed the party yesterday and had some nice views, simulator drives or some planetaria visions or so. Yeah, it was interesting thing. The only what I would say and raise as a concern is next time give us more time for something like this. Yeah? But it might be we got a discount so that more of you want to re-go there and then pay on it this time. Yeah, I don't know. Let's see it how. I don't know how this is. But the good of these is usually there's not so much a queue for a lot of these stuff, right? If you think about normal stuff or so. And I know we have done something once at Disney where you could go to a roller coaster and you had to run not to get into a queue. Yeah, so that was convenient. That was not like the fast pass, you know, you can pay for a lot and so many people are in front of you still. Yeah, it was a really convenient thing. Now, moving over to some business, of course. This session this morning is about high availability. And just to get it kicked off, yeah, who of you is using some sort of high availability today? All right. Who of you is using SUSE-based high availability today? Okay. Who is using something other Linux-based high availability? Okay. And that means, as you raised the hands at the beginning, you must run something else than a Linux-based high availability today. Sounds so, yeah? Okay, excellent. So, we could start and end with this slide only, because that is all we need to tell you about it. What we do at SUSE, and what we will talk about in the next hour, is about SUSE high availability, how we made high availability easy, quick, and anywhere you need it, okay? But however, we have to fill the hour, so that's okay. We will tell you a little bit more. My name is Kai Dubke. I'm the product manager for the high availability product. I'm the one who usually bridge between the customers, partners, the business-suited guys, and then the long-haired engineers. And as an example of a non-long-haired engineer, we have Christopher Grönlund with us, who is the architect of our HA solution, who will then go into the technical details. However it is, if there's any question or so, feel free to raise it. I mean, we can handle this pretty interactive in this session, I believe. We are available later if there's any question or so, or you can reach us via email.
Highly available.
Yeah, close to, yeah. So we have no clones of us, so it's good because I don't believe the company would pay 2 seats then in this case, yeah, for the plane. Okay, let's go into this and kick it off. So, first of all, on this time, let me invite Mr. Murphy. I believe every one of us knows Mr. Murphy, then and now. No one likes him, but that is simply a matter of fact. It's worldwide working. That is interesting word game with this, yeah. So we see faults occur, yeah. It's simply happening. Whatever you plan, however you feel your data center is good enough, there might be something you are not aware of, yeah? And that can be crazy things. I had a customer where the roof, the ceiling, drops down because of an architectural error, yeah? How do you predict this happens, yeah? It just happened. Luckily, no one was hurt by this, but the data center was dead. I had a customer where a power water tube exploded. You say, oh, a little bit of water, but it was one of the main lines in Germany with close to 2 meter diameter, okay? And that exploded directly into the data center. Okay, it was some in the middle mountains where you don't expect flooding, right? A fire protection, okay, but not flooding. So things like this happens, and of course no one, I believe, should build a data center in an area where earthquakes are usually happens. Yeah, I wonder what Silicon Valley would answer to that or so, because I would not build a data center there, but that's reality sometimes versus theory, right? However, every time something happens, you lose either data or access to the service. And that might impact your business, okay? And the question then is, how much is the impact versus what can I do to protect? How much do I have to pay to protect for it? And to give you an example, I would say, does Google need high availability? People think about it. So I would say no, because without Google, people can't find an alternative because they can't Google it anymore. Okay. Of course, for the stock, it would go down, but so somewhat like this, it's always mixed scenario. A question we get frequently is, oh, look into this with all the cloud stuff available, with all of these other technologies, farms, web farms available or so. Do you really still need HA to sell? Of course, that you are here proves somewhat that there's an interest in it. And of course, it's pretty easy. For whatever you do, yeah, usually what gives you this virtual availability, like in a cloud, you need something which monitors that, yeah. And there's a Latin speech about who watches the watcher, yeah. And that really is a case. If you have a cloud running and you want to monitor services to reboot, redeploy, whatever you want to do, this monitor has to run 24/7 and must be available, right? Because else Mr. Murphy will tell you if you shut it down for a while, something will happen, of course. Yeah? And there are other examples for it. And if you look into this, the cloud example is a pretty good one. You know that SUSE offers OpenStack-based cloud, right? And on all of these levels, we build it in. So, and that is exactly the same technology we have also as a separate product in case you don't want to run the cloud, right? So it's always a mix of this. But because we got the feedback by the enterprise customers, yeah, we said cloud is not just about being agile. If you want to run a cloud enterprise ready, you have to have the HA in it, okay? So, and that means we can start with the SUSE high availability. SUSE high availability is an open source based solution. All what we do is open source. I still wonder that people ask me if something we release or do, is this available as open source? The answer is yes, we are an open source company, right? The goal of this, finally you see the three bullets here, is ease of use, is integrated, and virtualization agnostic. And the ease of use really means to give you a tool or tool sets to manage that the easiest way possible. If you run HA, then you know HA is complex. That it is. Yeah? There's never a simple solution for many of these HA tasks. However, a lot of things you have to do in an HA setup are always the same, right? So that means we worked on this to make sure you can set up it easily, to get it easily kicked off, yeah, to then concentrate on the special things you need for your environment instead of running thousands of scripts or whatever you need else to set it up. Fully integrated means what we do on the high availability stack is developed and compiled, for example, maintained together with the SUSE enterprise server. So whenever we need an update by one or the other, we can do it because we built both. So that makes it much easier to upgrade, to get patches into it, and something like that. Yeah. And last but not least, virtualization agnostic. You will see this pretty often because it's an important piece of our message and idea behind this is whatever we do, we make it in a way that it doesn't matter if you run it on a physical box, if you run it on a physical box by Dell, Cisco, HPE, IBM, Lenovo, and I have to name every partner, but I don't have time for this, or if you run it on a virtual box, or in a mix of this, right? So we don't know what your data center looks like. And why is this so important? That is because you create a standard setup for your HA setup, how you run HA, and then you can apply this setup to whatever hardware you want. We also have specialized pieces optimized or adjusted for the remote console of HPE servers, right? We have the same for Cisco and so on. But that is something, if you say, hey, I'm a total HP shop, I'm a total Lenovo whatever shop, yeah, then it's okay that you say take some advantage of some special stuff you have. But many customers try to avoid this type of login just by the architecture of a stack, because if you want to move, then you have to unbundle all of this and retest. All right, move on. Just a plain list of features, and just to give you an overview what is in the box. We start with a plain, simple thing for HA, you could say. That is, there's a service running on a box. For whatever reason, the service getting down, and then we start the service on another box, okay? You might, all of you not already, but I had this in the morning that someone asked me, just curious, what means high availability? So it's not, we believe it's a simple thing, but some customers still say, oh, what is it about, right? In addition to that, we give you a cluster file system. In fact, we give you two cluster file systems. The one is a recommended OCFS2. The other one is a GFS2, which some customers might have already data on. It's plain thing to make it easier for you to migrate in case you want, because you don't have to back up and restore the data or migrate the data. And the cluster file system is pretty important to make sure that not just the service is available, but you can make data available across the nodes, something like that. We beefed this up with a clustered Samba thing. Someone using clustered Samba? Okay. The clustered Samba is something where Microsoft clients can connect to a file server, and with clustered Samba, you get it in a high available, scalable fashion. Yeah, it's interesting that we have a couple of more Microsoft-focused customers who use this stack because it seems that is a nice solution for them. Yeah, I don't want to bash someone else, but the customers just feel that is a nice solution. Again, you heard about the virtualization agnostic. I think it's on some slides more. We have a full support for all of our architectures. I have to admit the Raspberry Pi is not supported, okay? Because we don't see it really as an enterprise device. Might be changed with a WAC version of it, which I heard might come sometimes, yeah? I can't imagine a Raspberry Pi as a WAC, but okay. So this way, you can use the same setup. Doesn't matter if you have a single architecture data center or you have a mixed architecture data center, yeah? Or you might think about migration from x86 to System Z, or some customers in the other direction or so. Who of you is running a mixed data center with more than one architecture? Okay, some hands up, so I think that is a nice thing for you. Just in case, if you want IBM System Z, or I think they changed the name to C System again, yeah. This HA stuff we are talking about, the base HA extension, is part of the System C subscription. So in case you have this running, it's already there. You can use it to even beef this highly reliable platform to give it a little bit more HA on top. Yeah? On the right side, we have some green stuff, which is SUSE Unique, and on top we have a network load balancer. The network load balancer is simply something where you have a web farm, a farm of network-based services, and we make a load balancing between them. However, while this is part of the standard Linux kernel or so, we also have a remote synchronization of more than one load balancer to make sure in case something happens, you have a seamless failover from A to B. Yeah? And that is interesting piece. We are talking HA, right? So, and in case of a load balancer scenario, we can make this transparent failover, which is really nice thing to have in case something happens. So with respect to the SUSE Unique things, we included data replication. That is a tool, a project called DRBD. It's a network-based data replication, which can do synchronous, asynchronous replication and all this stuff, just to replicate data from one disk system to the other disk system. Yeah? And that is independent of the hardware. Every hardware vendor has something like this in the portfolio, of course, but it's usually limited to a specific vendor, and this way you avoid a vendor login on this part. We also have something which is a node recovery piece that is called the Relax and Recover tool, REA, because in case of an emergency, that is what an admin should do, relax and just let the system do the job. Yeah. Some customers tell me, oh, we don't need it, we just redeploy a new system when something happens. That's okay, we just give you tools. Yeah? You can look into this and then decide what is the right way to handle it. Yeah? That is a framework. Yeah? Just to make this clear, you can't just install and say, oh, now it's installed, it's there. It means you have to set up and test it appropriate for the simple reason, in case of an emergency, you can't redo what you had to do on the initial system, right? Because it's gone. Yeah? So you have to test it firsthand and not after something happened. I have to admit, I had a customer who made it or tried it the opposite, and that has not worked. Okay, so just as a caveat, but that applies to every disaster recovery strategy, right? You can't just make the plan and don't test it, because when you then need it, it's better you are not in the company anymore. Okay. We have a nice web GUI that is a HA web console, which I really like. And I know many of our customers are more traditional Unix people saying command line works. Yes, I'm using command line pretty well, and I believe engineering without command line, I could not think about it. However, in daily operations, it's much easier to see a green button somewhere than to issue a command, right? It's much easier to get some visual impression of a cluster, yeah, than to have a XML file or config file or whatever, and then in your mind you build this map up, okay? Just at this point already, all what we do equally for the command line and the web GUI. Sometimes you can do some things on the command line where we feel that is not appropriate for the GUI, because that is not something you can click on really, because you have to tune a lot of parameters or so. But you can do both, yeah? And admins usually mix it today, right? So daily operations or things you just do once a year or so might be a good idea just to click it together, where if you have to repeat something, you do it on a command line and build scripts or something like this. All right, and the last one, we will talk about this in details, is unlimited geo clustering, really to give you the final solution for issues on a site base or something like that. All right. I think, let me skip this, as I will run out of time at some point. By making this happen, we address a couple of use cases. Don't want to go through all of this list. Just, it is always about mission-critical stuff we are doing, right, or our customers are doing. That might be business-critical, that might be mission-critical, or whatever. We do it both active-active, passive-active, or active, passive, active, also means whatever mix you want. At this point, let me give you some advice. It's not a good idea to make whatever is possible always happen. Complexity is a friend of Mr. Murphy, right? Or an enemy of your operation. So just because it's working, it's not every time the best idea to make it happen. Just to give you a reference, and we have a couple of this in many areas, so if you say, hey, has someone already done something similar to this? You know, every customer is somewhat different, but there is something common usually. That is in pharmaceutic area, a customer. For me as a German, yeah, I always can say, in Germany, we can't avoid SUSE, yeah, because the air traffic in the center of Europe is secured using SUSE systems, which is good because I fly a bit, so I know it's stable, yeah, and no one else can hack, so don't shoot me down. If I say, oh, let's avoid the planes, do the train system, doesn't work. The train system people use SUSE as well. And I don't have to talk about German car manufacturers, I believe. They all use SUSE as well, and many of the other car manufacturers as well. So it's not a good idea to try to avoid us. It's a pretty good, interesting thing. We should make it a map and nice graphical thing of this. So with respect to the Geo Cluster stuff, think about you have an HA system running. Then you might have an HA system in a single box, a tiny little box. You say, what is this for? If you run HA already, yeah, it might be just operational easier because you can send a technician to such a system if something fails on a schedule instead of an emergency, right? Because sometimes it's not a big thing happen, but a small thing like just a server, memory is corrupt or something like that. But usually you have two boxes and then you give them some distance, right? Because if you have it in two racks and there's a fire in the room, doesn't help, so you have to separate. You might even then say, oh, what happened if the building is flooded or breaking down? I don't hope this ever happens, but you know when you think about HA, you think about this crazy stuff. So, okay, get it to another building. Then get it to another area of the city, yeah? And just bring it together on this slide. That is what we have in the middle. We call the metropolitan cluster then. But now what is if your complete site, your metro area, is out of order? Yeah, I don't think about an asteroid coming down or something like that, right? So that, of course, is something people might say about, because when that happened, then we have different problems than our data, yeah, personally thinking about it. But I had it once, I was in San Diego, and we had a power outage for 8 hours. 8 hours power outage, yeah. You have power supply on site, right? Think so. But what is with all the stuff around you? The routers, yeah, or so. What is with your partners or so you have? And to make such scenarios still your service up and running, we offer you a geo clustering. And the geo clustering is something where you get a cluster of clusters with an unlimited distance in between. Yeah, you can switch from one side to the other. Yeah, be it, let's say, from Washington to DC to state of Washington or San Francisco or whatever you want. Yeah, or you could switch or put something on the moon. Would be a nice project with Google or so, yeah, because they have the money to pay for it.
I'm waiting for Elon Musk so we can put one on Mars. That's
right. So yeah, I know some physicians, so they sent some Raspberry Pis or so already to the atmosphere. Yeah, so we might get some of them into such a Mars ship. So I don't know, it might be a little bit expensive still. Right? So whatever it is, just a summary of these different setups of clusters. Right? We start as a local cluster where you have it, be it in a box, be it in one data center. It's pretty easy because it's just where the cable and the admins are close by, right? That is where it starts usually. Having the metro area stretched cluster where you have it in different positions in your city. However, keep in mind we are talking availability and redundancy. What's about the lines between and something like that? That can already get complex. And when it starts to get beyond 15 milliseconds as a latency for data transmission, we switch to an asynchronous mode and go to geo-clustering. And that is simply a matter of fact and an issue of speed of light. So, sorry, yeah, we are working on this. I gave them an order, but we still want to wait for it, and it might be in a couple of years we can fight it, really. So whatever it is, beyond 15 milliseconds, yeah, we switch to geo-clustering. We translate this to something like 20 miles. Yeah? If you have a dark fiber, where you really can guarantee this latency, then you can go to something like 300, 400 kilometers. Okay? So it's a timing issue, it's not a distance issue. Yeah? As said, it's a matter of speed of light, which is bound to timing. This is a picture of it, so you need at least two sites, site A, site B, yeah? Each site wants its own autonomous cluster, right? And then we build a cluster of cluster, just saying, okay, we monitor the site, and if something happens, fail over. To get some more automatism into this, we need a third side to make sure that not a network issue, yeah, just makes a cluster switching. Usually, customers tell us we don't need this automatism. We just need the monitoring piece, yeah, because the decision to switch a complete data center from one side of the continent to the other or from one continent to the other is nothing a simple admin should take. It's always something where a VP or so has to sign in and nothing you do within seconds or so. Yeah, because you really want to check, is this just a hiccup somewhere? Like, for example, a power outage. Usually you believe it's a maximum of 10 minutes or so. So you might want to wait this 10 minutes because else you get other challenges, organizational challenges like SEC filings or something like that, right? You would like to avoid it, yeah, often. Okay, in a summary, what we can do and what we do already is fighting Mr. Murphy. Yeah, I know that always ask him to show up, but I'm in luck it not happened that much. We do a service failover on any distance, be it local in the data center, be it in the rack. We have customers running stuff in a single rack just for more convenient service or so. Yeah, and I have one customer running around 8,000 of these clusters, which is a nice number, right? Up to geographical distance, where customers have really 200, 300, 500 kilometers between data centers, yeah, just for the case something really bad strikes a company, okay? We can reach up to 6 nines of availability. Who knows what this translates into unplanned downtime? 6 nines? That is 32 seconds a year unplanned downtime. That is heavily tuned stuff, okay? Just to give you an example, telco providers have an interest in this, but not for all systems. Someone knows what system they run at 6 nines? That is a billing system. If they can't bill you, they don't patch you. All the other systems, they don't do 6 9, and that for the simple reason, every 9 doubles the complexity of a system. Yeah, and at some point, you have to really balance what you have to do on resources and what you might get back. Yeah, it's really not easy to find the right balance. Yeah, it is like security. If you make your system too secure, you might not even be able to log in anymore because you made a simple mistake or so. Yeah, if it's not secure enough, we don't need to talk about this, right? On the other side, the biggest issue today for clusters is not the unplanned downtime, because that is something we cover pretty well. It's the planned downtime. Of course, then and now you have to upgrade your software stack. Then and now you have to upgrade your database and something like that. All of this cut into the uptime. And the final goal of us is not so much to avoid the downtime, but to have the uptime up, okay? And to make this easier, we give you something like rolling updates, where you have a cluster, and in the cluster, you start with one node, update the node, then you go to the next one, and during all of this, you still have a cluster available. Of course, not with a 2-node cluster, because in a 2-node cluster, if you take one out, then there's no redundancy anymore. But if you have more than 2, then that is a nice thing, and you can go up with a cluster, and once everything is on the new version, it switched to the new version, okay? That means less downtime, less planned downtime, or you could also argue less overtime for the admins, because such stuff you usually traditionally have to do weekend, night, or whatever is the right time for it, usually not a pleasant time for admins. All of this is beefed up with easy setup, management, support tools. It's okay to set up a cluster. How often do you set up a cluster? Once in a lifetime of a cluster, right? Then you run the cluster for a long time, hopefully just working cluster. But we know then and now something might happen. I'm sorry to say, but that is Mr. Murphy showing up not just in the building, but also in some other areas. So we give you the tools, and our support people the tools, in case something happens, really to look into details, to say, okay, when did it happen? What can we do to make it working well? It's virtualization agnostic. I already pointed on that. And we are a leading open source high availability company. We did this geo-clustering stuff. We support the geo-clustering for a long time meanwhile. And this is the only enterprise geo-clustering Linux open source solution available. Okay, that should tell you something. And now, handing over to Christopher, and I'm sorry, I again took a little bit more time than thought about, talking about roadmap and technical details.
Sure. So yeah, just gonna grab that. Yeah, so I'm just gonna go to the next slide. And oh yeah, now it's updated. Fantastic. So this is kind of a rough outline of the roadmap for SLE 12. So we have Service Pack 1 was released a year ago. And some of the new features that we added in Service Pack 1 is, for example, support for running on Amazon Cloud. We added the new updated web interface, which I'm going to show you later. We added new features for Geo Clusters, and of course, all the stability fixes and things that might be necessary. But in general, I don't think we actually had any major issues like that. Today, or this week, we released the Service Pack 2. The main change there is that we switched to the new web interface as the only option. For Service Pack 1, we still had the old design for Hawk available as the default. And this was to give people time to update their training material and screenshots and things like this. Or if someone is used to the old interface, just to give them some time to get used to the new one before we just switch them over. Another big feature is Power LE support. And the other big feature is MD cluster, or clustered RAID, which we had a talk on that yesterday. And that, I think all of the talks for SUSECON are filmed this year. So that's going to be available later if you want to know more about cluster MD. But the main benefit of it is extremely high performance for clustered RAID. So it was possible to fill the same niche with the CLVM and the cluster file system and the CMRD before that we had, but the performance was not as good as one would hope. So MD cluster is a complete redesign, a completely different way of setting this up, which ensures basically the same performance, or even in some cases better performance than a local RAID 1, which is a bit strange, but that's where our benchmarks tell us. For Service Pack 3, so the next release, some of the things that we're planning are, for example, Azure cloud support. So to complement Amazon Cloud, we're going to support Azure Cloud. So really, the core cluster technology works fine on both Amazon and Azure today. The main thing that you need is some kind of fencing support for these setups. If you don't know what fencing is the way that, let's say if we have a 2-node cluster and one node stops responding, the remaining node has no way of knowing if that other node is still up and running, or if it's just a network connection that's broken, or if it's actually down. So there's no way to know if it's actually still providing services. So for this, we need fencing support, which is an alternative pathway to turn off the other nodes. So the surviving node can say, okay, I'm turning off power to this node, and now I can be sure that it's not providing services anymore. I can start up the services this time. So that's the main thing that we need special support for all the different platforms, and that's what we're adding for Azure. In addition to that, what we're focusing on is to continue providing more help for making setup and administration easier. So we're adding bootstrapping scripts and tools for setting up a Geo Cluster easier and easier. And we're also adding wizards that help you set up specific scenarios. So if you have, for example, you want to set up the NFS server, or you want to set up Apache web server with a database, we then have complete wizards to tell you step by step what you need to do and can automate that for you. Yeah, so this is a look at Hawk, the web interface that we have. We also have that available in the tech showcase. So if you want to see more and play around with it, this is the one we added in Service Pack 1, and we made it the default in Service Pack 2. You can come to the tech showcase, and I can show you more about that. I'm not going to go into details about the features there, because if you haven't seen it, then the new features don't really make it much sense. But yeah, so another thing that we have that's kind of an interesting point is that we have support for monitoring services that run inside virtual machines that the cluster is handling. So for example, you can set up a cluster to manage and migrate virtual machines between nodes. But what we also provide is tools to monitor services running inside those virtual machines, so that you're not limited to just looking at is the virtual machine running or not, but you can also make sure that the services that the virtual machine is supposed to run are actually running. And if that's not the case, you can fail over to another version or restart the virtual machine. So one way to do this is to have monitoring agents that just look at the virtual machine without actually having any kind of custom software running inside the virtual machine. So this can be useful if you, for some reason, can't run SUSE inside the virtual machine. You can actually still monitor services running in that virtual machine using the Nagios monitoring plugin. If you are able to run SUSE HA inside your virtual machines, you can run something called Pacemaker Remote. And this can also run on non-virtual machines. So you can use the Pacemaker Remote monitoring system to actually extend your cluster beyond the limit of 32 nodes, which is the limit for a standard cluster that we have. So a normal high availability cluster is limited to a maximum of 32 nodes. But using Pacemaker Remote, you can actually blow through that limit and have hundreds or even thousands of machines in your cluster. And this is actually used by SUSE Cloud. So in the SUSE Cloud product, they use Pacemaker Remote to enable HA for compute nodes as well. So you have HA for the admin nodes, and then using Pacemaker Remote, we're also able to extend HA to the compute nodes. Yeah, so here's a list of new features in Service Pack 2. I'm not going to go into too much about that because I already did in another slide, but as you can see, there are some other new features beyond the main ones that I mentioned. Again, if you're interested in knowing more about that, just find me somewhere around here and I can describe any of these in detail. So we keep saying that one of our focuses is to make things easy, and that really is the core thing that we're looking at now, because the actual cluster software is working. We already have that up and running, it's stable, and that's all good. The main thing that's something that we want to keep improving on is making it easier to set up and making it easier to troubleshoot, because especially the troubleshooting part or the monitoring part is something that a lot of solutions leave out, or that you don't really talk about. You just show, oh, it's really easy to set up and get started. And then 2 years later, when you're having some problem with your service, it's almost impossible to find out what's actually going on. Where is it running? What happened? All that stuff. So that's something that, through experience, we found that we as developers of the HA software need these tools, and our customers also want these tools. And these tools are also helpful for support cases where we can just run a single command and get a complete log of the time frame for when something happened, and we can see, okay, so this is exactly what happened. This is logs from this node, and now it failed over to this other node, and so on. So setting up a cluster is a two-command setup for 2 nodes. For every additional node, it's a single command. So you just run cluster init on one of the machines, and then once you have a cluster up and running, you go to the next machine, you run cluster join, and that's really all it takes. At that point, you have a fully functional HA cluster, and you can start running service in that. Yes? No, it is not. So the question is OCFS2 a requirement? No, it isn't. So this is just something that we added to make the setup even easier. So you can optionally choose to have it configure a shared disk so that you have that available right away. But that's totally optional. We're also, the cluster init script is also able to set up fencing using SPD, which is the storage-based fencing mechanism. If this is something that you're not able to use, that is also optional, and you can use a different kind of fencing device. For example, if you're running on Amazon Cloud or something like this. Yes. Yeah.
Is the Hawk interface high available too, or is it just simply running on each node?
It's simply running on each node. Yeah. So it's highly available in that sense because you can just log into any node and you get a web interface. But it's not running as a cluster service.
But you could run it via virtual IP if you want to add it.
It is possible. There's not really any need for that. Yeah, so that's really it. Once you have your cluster up and running, we have a set of wizards, as I mentioned before, that make it easy to configure various cluster scenarios. It's not necessarily that you have to use these wizards to actually configure your cluster, but I find it's nice to have these wizards just as a hint or a showcase for what it is possible to set up and how you would set it up. So this is useful just to look at the list of wizards and say like, oh, okay, I can use it to set up an NFS server, and these are like the recommended settings for a basic NFS setup, and there's documentation for what all the parameters mean and so on. So that's a really nice feature to have. So one of the new features in Hawk is the batch mode. This is just to make configuring using the web interface easier. But it's also useful for figuring out if the configuration is actually what I mean it to be, because we also have a simulator as part of the batch mode. So what it is that you can make a set of changes to the cluster from the web interface, and before the changes are actually applied to the production cluster, you can see a list of exactly these are the changes that are going to be made. The configuration is validated by the cluster software, and the whole cluster setup is simulated to show, okay, so if this configuration change is applied, this is what's going to happen to the services. So this service is going to get stopped, this service is going to move to another node, and so on. So you can see if you made some configuration error and you didn't mean for a certain service to be stopped or moved, you can see that before applying the changes and correct the configuration. Yeah, and finally, the other tool that we have in Hawk is the History Explorer. So this is simply an interface to look at a certain time frame and see, okay, so these are the events that happened, these are the actions that the cluster took, these are the logs from all the nodes, and so on. Yeah, as Kai mentioned before as well, not everyone wants to use the web interface. That includes us. So we actually have all of the commands available from the web interface are also available from the command line using the CRM shell. And you can do the complete configuration of the cluster just using the command line. And monitoring and the History Explorer and all of these tools are also available as command line commands, I guess. Yeah, Cluster MD, I'm not going to talk more about that. Unfortunately, today it's too late to actually see the talk live because it was yesterday, but you can see it on video once the videos are up and running. Yeah, I think I've already talked about the outlook for Service Pack 3. So Azure support is the big one. And I'm just going to move into the future, and then I'm going to head back to Kai.
Okay, thank you. And now I started with, we don't talk science fiction like this, what we heard yesterday morning, right, about getting down into Earth or so, but more about science. But now I have to talk about future, which always means a little bit about fiction, right? First of all, let me demand something from you, and that is your input, okay? If you feel we should do something different, add something, you might want a different stack or so, you feel, oh, that's needed or so, then please tell us about it. Based off customer feedback, we build up the software and make sure it fits the market. And just in case you don't have looked at it yet, but you look at it, you might figure out that we have features of many other scenarios in it, because we had customers moving from HPUX to our solution. We had customers moving from Solaris to our solution, customers moving from Windows to our solution, or other third-party high availability solutions. And everyone, of course, asked for, give me what I know, right? The usual thing is, we know about it. You want the same, you know, but it must be better, okay? Yeah, often cheaper, yeah? I think that is in line with this. So please help us to make this happen, yeah? Of course, I don't have a Pixie available, right? So if you ask me for something which you want, and we might not have it today, yeah, I'm not able to provide it tomorrow, right? But usually when we talk about it, we will find a way to give you help to make it happen today and then have a transition, something like that. And in some cases, I figured out that just because you are used to do something, it might not automatically means that this is something you might want to use in the future, to say it in a neutral way, okay? So these are topics what we are looking in, and we want to ask you, okay, so where to go for? We made a quite good job on failing over. So something happens, fail over, that's a given. We can do at any distance, great stuff, right? But for us, for the future, a goal is to avoid failures. Because just sitting there and waiting for the failure is an easy thing, but we would like to do some more monitoring. What comes to our mind is something like memory stuff. You know, the systems log ECC errors and something like that, but if you have whatever amount of corrected ECC errors, it might be useful to get this node out of the queue, just to avoid the hard failure which might happen later. Yeah, that is easy, right? But I believe there are other stuff you feel we should think about it also and look at it. So we need input on that. What you, by your usually bad experience in this case, yeah, would say, hey, if we could monitor this, that would have saved us something, so let's check for this for the future, okay? We look still into what we can do with virtualization, containers, clouds. You have heard about the remote monitoring we do, yeah? So to check stuff that could be virtual gas, that could be outside systems. For example, if you run a big SAP system, which is connected to a vendor or a customer, and you have a communication server somewhere else, you might want to monitor this. Okay, that we already can do. But is there something we can do better with respect to the cloud stuff, to the container stuff or so? We get a lot of input by our own OpenStack cloud people, right? And we added a lot of stuff already. So usually I expect that cloud customers talk to them as well and we get the feedback. But if you want something else, which might be not our cloud solution, then you might have interesting needs, requests we could add, and you might wonder then later that they will also be part of the cloud, of our cloud solution, so to make it easier for you to move to this at a point. And then, yeah, we sometimes say we have covered all HA scenarios. You might prove me that this is not the case, but we have a local, we have a metro, we have a geographical cluster. Someone said, oh, now we need universal cluster, but we have not built any distance limiting in, right? It's already unlimited, so what should we do, right? And yeah, while we joke about mass and so, sorry, that will not happen in practice, not during my lifetime, I believe. Yeah. So, but is there something what we should look into where you say, oh, that is other than what we do today in these setups, where we can do just help you to make sure it's working better, and might be having some other customers then joining this. Scalability. So you need 2 nodes for HA. That's pretty given. If you want to have rolling updates, you need at least 3 nodes, because when you put 1 node out, you have no redundancy more. So we have customers running between 2 nodes and some going up in special case scenarios up to 40 nodes and more. Yeah, but what is the right number of this? Yeah, and if we talk to these customers, if we talk to a customer running 2 node clusters, they are pretty convincing that is the only way how you can run a data center. If you talk to customers running clusters with 30 nodes, of course they are pretty convincing that is the only way to handle, and all in between. Yeah. So we have people asking for what can we do, what is the right number of nodes. With a pacemaker remote, think about 32 nodes in the core center of it. Everyone manages 10 nodes, then you get more than 320 nodes, right? So that is not a bad number for an HA cluster, right? Many people already tells me that is not a domain of HA, that is then cloud. Yeah, so sometimes it's not black and white, what is the right limit there? And of course, what we might look into the future, some engineers in the community do, to think about HA of 10,000 nodes. I have to say, I would not like to be the admin of this, yeah, because 10,000 nodes is a big lot of services to run, and I believe I would not be able to really overview the scenario anymore and the effect it has, yeah, independent of the cool tools we have, yeah, it would be amazing. So give me feedback on that. And then usability. On every level of the life cycle, that means set up a cluster, set up a service, running then the services, adjust it till you get it out, yeah. We're working to make it easier to manage this, to give you the right tool for the job. Yeah, as said, for daily operations, I really like the web GUI. If you set up a couple of hundreds of clusters, you want to do it on a command line. So there we have these tools. So if you feel something would make your life easier, please tell us about it, right? So, and then we will look into this, work with the community, work with our own engineers to give you some help on this. All right, that said, we are done with this session. We now have time for some questions. You can grab us around. So I have to go to another session after this, but I will be available as well. Christopher is available at the SUSE booth then for HA. So if you have questions, please come up with the questions. Else, thank you very much for being here today. Thanks. Okay. So, any questions? Else, we will give you 4 minutes back.
Yes.
You were asking for usability, things like that. I'm coming from AIX and OHA, and then we have some interface for managing users and configuration file management. So we have all the nodes and so is there something in the HA solution?
So the question was about how to synchronize data between nodes to get configuration syncs or so. Yes, we have this in place. And by the way, that happened due to a customer running the same scenario like you, coming from the same platform. It's called SUSE Sync 2, and that not only synchronize data, but it's also capable of changing data on the fly. Because sometimes you want to have 2 nodes getting a config from A to B, but just adjust a little bit. And we can do both, means one-to-one, and have changes. Yeah. That is available. Thank you. So, other questions?
This synchronization, is it compatible with other modules like DB2 or MySQL?
This so the question is if the synchronization I talked before is compatible to databases or so. This synchronization is for config files. It moves config files around or adjusts text files. It's not a database synchronization tool. For that, we have to look into the database tools which are available to make it happen. Okay? Thank you.
We're working to implement SUSE with our SAP environment.
Yeah.
Is there any kind of plans for SUSE to work with SAP and come up with a reference build on what is the best setup for that? Because we're looking at it and we have so many options there.
So thank you for this question. The question is about if there are recipes to work with HA and SAP, and the answer is yes. And that is for a simple reason. SAP develops on SUSE Linux Enterprise. So that is a primary platform they use. So everything works with them. SAP developed SAP HANA with SUSE, which includes high availability, right? If you have a subscription for SUSE Linux Enterprise for SAP, it includes HA. It's part of it, and it has additional resource agents to fit into this. So if you want to run SAP with SUSE HA, please do me a favor, look into /for-SAP, because it really targets this. And for this scenario, we have all the recipes available for download. We have guides to make it happen. We even have wizards to set up a complete SAP system with HA. That means if you want set up SAP traditional, you know you have always to read these thick books, yeah, and download all the release notes. And you still have to download a lot, okay? It's a very complex setup. But what we can do is, with a wizard, to get it down to just answer what's needed, and then you get a, let's say, mind-reading setup just working out of the box. We have a special booth here in the showroom for SAP, for SUSE Linux Enterprise Server for SAP applications. And the people around there, they know about the HA stuff and can guide you to the right thing. If you don't have time, just contact me and I will connect you. Okay, thank you very much. Yeah, enjoy the day, enjoy the remaining session, and when you fly back, might be tomorrow or so, have a safe trip back. Thank you.